Hi everyone, this is a video on topic 12, alternating current. And this video has two parts. The first part is about the production of AC, and the second part is the explanation on the terminology of AC. So this is the first part. It's about how the alternating current is being produced. I hope you can focus on what I'm going to explain, so easy for you to catch up and understand the topic. In conjunction with this video, you can also refer to the presentation slide that I have provided via eLearn. So now, here we go. Before we go further, let's refer back to the Faraday's law. This law states that when magnetic fields cut the conductor, or conductor cuts the magnetic fields, whichever is moving, the EMF will be induced onto the conductor. Basically, the magnitude of the induced EMF depends on the three factors, which are the number of turns of conductor, the speed of cutting, and the strength of magnetic field. And if we refer to this diagram, it shows you the basic generator of single loop rotating and cutting the magnetic flux which travel from north to south in a straight line. Refer to figure A. Assume that we consider the top point of the conductor loop or armature to move and cut the magnetic lines and induce EMF onto itself. Note that the rotation of loop is in the clockwise direction. From this position, the point on the conductor is moving parallel to the lines of flux and cut the minimum flux, thus the minimum EMF is induced into it. As you can see on the graph, the value here is 0. When it reaches quarter of the turn, or 90 degrees of rotation in figure B, it will cut most magnetic flux and maximum EMF is induced. What we have on the graph is the maximum value or peak value at 90 degrees. If the generator is connected to the external circuit, the current may flow through the conductor. The direction of the current flow can be found by using the Fleming's left-hand rules for the electron current. As the loop goes along until it reaches 180 degrees of rotation, where it cuts less magnetic flux, the induced EMF drops back to the minimum value, or 0, as it moves parallel to the lines of flux. When the loop turns to 270 degrees of rotation in figure D, it again cuts the most magnetic flux and again the EMF induced reaches the maximum value. But now the direction of the EMF is in the opposite direction of that when the loop was at 90 degrees of rotation. So what we can see on the graph is the negative value of EMF. In the last quarter of turn, the induced EMF again dropped back to minimum or 0 value when it reaches 360 degrees or full rotation. So, for one complete rotation of the loop, one complete cycle of AC voltage or EMF is induced. If the rotation continues, the cycle of AC waveform also continuously produced, and this waveform is called sinusoidal or sine wave. Basically, during the operation of the generator, AC voltage is induced, and this generator is called the AC generator or alternator. But this AC also induced in the DC generator. There is one component in the DC generator used to switch this AC into DC to be supplied to the loads. That component is called commutator. AC and DC generators will be discussed in the advanced topic of electrical fundamental. Now we come to the end of the first part of the video. I hope you could understand of what I was explained just now before we go to the second part of the video. So see you in the next video. Bye.